This is an interview with Meriem Bendris, data scientist at Nvidia. We will go over what is a data scientist, especially at a company like Nvidia, and how to get there from any background. I hope you enjoy this interview. I'm also partnering with Nvidia for the GTC event, giving away an RTX 4080 as well as 10 Deep Learning Institute credits for following short courses on the Nvidia platform. The only thing you have to do is attend GTC, which is the free Nvidia event, and take a screenshot while attending one of their events. Then you have to like and comment under the video for me to draw a winner. You are currently working at Nvidia, but how did you get there, and what's your scholar background or academic background to get there?
Hey, hello everyone, and thank you very much for this question. Yes, so I actually studied artificial intelligence and decision system at l'Université Pierre et Marie Curie here in France. And after that, I did a PhD on signal and image processing at Telecom Paris Tech in partnership with Orange Lab at that time. I was studying machine learning applied to video to identify people in TV content. So after that, I did two postdoc, one at the University of Liverpool, the second one at the University of Marseille, working on natural language processing, speech processing to identify people in videos. So that's basically my background. And after that, I joined a company that is developing software for simulation and 3D design. I joined the research department there, where I worked on machine learning and especially deep learning techniques applied to images, 3D, robotics, and also some natural language processing. Well, basically, after a few years of working in that research department, so I wanted to, challenge myself and find, change a little bit the environment of the projects that that I was developing, and then like I saw this uh, offer as a solution architect, a data scientist. And to be honest, I didn't know actually what was the role of a data scientist in that organization at Nvidia. Of course, I knew what Nvidia was. I knew as a data scientist, I was already familiar with the hardware stack. I knew also some research that was done at Nvidia, but I didn't really know what was this organization of a solution architect. And I just decided to apply and see, like, okay, so if it fits, it's fine, like if it doesn't fit, so maybe I'm just building my network and let's see. And then I had my first interview and still was not really, to be honest, clear what was that role. And I just, okay, so let's move on. And I had the entire process of uh, I think seven interviews, so which is quite
Wow.
classic at Nvidia to meet several people, technical people, but also I met executive people. I met also some sales people, marketing people. So in order to have like an entire view of Nvidia, and while I was having those technical interviews, I was really impressed about the level of knowledge of those people in terms of machine learning, deep learning, and also its application in different problems, for example. So I was saying like, if the role requires that level of knowledge, so I want to be part of this. And this is actually how I joined NVIDIA as a data scientist within this organization called Solution Architects.
And how were these interviews? Like, you mentioned that you talked with at least seven different people. Were they just like discussions to get to know you, or were there technical interviews? How were they like?
Well, it depends really on the interviewer itself. Some of the interviews were more about understanding if the culture, if I could feed the culture of NVIDIA, because this is really special, at NVIDIA. I was told that NVIDIA is speed of light. It's a flat organization, and it is really a flat organization. So there were some interviews to actually more understand if I would fit to the culture of NVIDIA. But for the technical interviews, it was more about understanding what was my level of understanding of AI in general and machine learning, what I knew about the hardware and the algorithmic techniques, again, so you don't need to know everything. The idea is to understand the level of knowledge. So there were many technical questions about, like the algorithms, how we train the models, and why we use this layer, this optimization, and so on. So yeah, so that was the idea, is to actually, like qualify the level of knowledge. And again, like it's okay if you don't know everything. Of course, no one can master everything, especially that the AI field is moving very, very fast. But I think the idea was to see if the candidate will be able actually to learn
Yeah.
like as it goes in that position also.
Yeah.
Yeah.
And how did you prepare for them?
Oh, well, so like again, it depends on the interviewer, but my preparation was more about, like taking my notes, like reading my study about natural language processing, about techniques for how we train models, neural network, machine learning in general, like some kind of yeah, just recovering some
Yeah.
notes, but also talking more about like my experience, because that's also something that was helpful, about the knowledge that I gained during my career on how to train models, for example, and the type of challenges that we can meet on training those models for different kind of domain. Because like at that time I was more working on computer vision, and once I joined Nvidia, I started working more on natural language processing and speech processing. That was something that I was doing during my PhD. So yeah, so this is how I just prepare the interviews, by just coming back to the fundamental of what is AI, and how we train the models, and why we use some of the techniques, and how we
Mm.
could solve some problems, and so on. Like it's really okay to say that you don't know things, because I think in interviews somehow it sounds like a little bit, weird to say at an interview that this specific question you don't know how to answer it very like into the detail. But I really think it's okay, because it's so much, big AI in
Mm.
general. So of course you have to prepare for the position itself. Like if it's computer vision, you need to go deeper into computer vision techniques. But again, I think it's okay to say like, oh, this specific thing, I'm not really sure how we are going to solve it, but like those are my hypotheses, and I
Yeah.
can learn about them.
Yeah, giving hypothesis and just how you think we should solve the problem is interesting, even if you don't know how to solve it. Like you need to say something and give some ideas on what you would do, or at least how you would start or approach the problem.
Yes, exactly. It doesn't mean that this is the right solution,
Yeah.
but I think it's okay, like there is no, like, it's not, today we are facing very, very complex problem, and there is no one solution that sounds very obvious that this is what you should do to solve that
Mm.
that specific problem. So we are really facing very complex problems. So yeah, just don't be afraid, and just give your ideas, and take it like it's a learning process.
Yeah, indeed. And speaking of a learning process, you didn't know really what was the specific data scientist role at Nvidia, or what you said was solution architect.
Mhm.
So may I ask, what is a solution architect at Nvidia?
Well, solution architect position at NVIDIA is quite a, like not really clear for everybody, but actually we have different roles. One of my roles is to actually follow customers and partners and help them developing their own applications, their own solutions based on NVIDIA technologies. So whether it's a hardware or it's a software or both of them. So first of the roles is to help them actually qualify the problem and help them to develop and customize their solutions based on NVIDIA technologies. So to give you an example, so in my role, for example, I specialize focus more on natural language processing and speech processing. So anything related, for instance, to add in speech transcriptions to your application, to, let's say, a partner or a customer who has already an application and wants to add into their chatbot the speech processing, like speech transcriptions and speech synthesis, for example. So we are actually helping those customers and partners to qualify, and also in kind of developing with them what we call POC, so proof of concepts, to help them make the best decisions in their infrastructure decision, in their technologies decision, and so on. So this is one of my roles, but I have many different roles actually. Basically, I also work in kind of demystifying some of the technologies related to my area of expertise. So I go to conferences, for example, explaining what is ASR models today, state-of-the-art models that are used, and what are the advantages and disadvantages of those models. I go also for conferences talking about deployment processes. So because, like we talk a lot about developing, training those models, but once we are happy with those models, how we deal with the optimization for the development after that. So I have this role of trying to demystify the entire process of the development of AI models, especially based on Nvidia technologies. And we have also, it's again within the same role of demystifying AI technology. So we have what we call the Deep Learning Institute, where we actually develop workshops with hands-on, specific to, well, one specific domain. For instance, we developed recently a hands-on workshop for conversational AI. We developed another one with two of my colleagues on how to train and deploy very large neural networks in a distributed way, and so on. And those workshops are basically like 1 day workshop that's 8 hours with lectures and also with labs where students would do some exercises, and at the end they have an assessment and they get a certification. So those are basically part of the solution architect roles. I have another one which is following the technology, and like AI today is like moving very, very fast. So one of my roles is to keep a track of what is happening in the industry, but also in the research part. So, and to be able to do that, basically, I usually try to dedicate some time to internal projects, to just, basically do things, because yes, it's really, like understanding the process of training, let's say, a large language model. It's like theoretically it's cool, but I think, like you learn while you are doing. So this is why with my colleague, for example, we had that internal project for a few weeks. We just decided to do the entire process of from data preparation until training of a medium scale language model for French and for Spanish, because I am French speaker, he was a Spanish speaker, and just we wanted to learn the entire process, and this is how we try to do it.
Does this mean that NVIDIA basically allows you to leverage your strength, and you kind of not decide the hats you will take, but the roles that you have are tailored to you?
Well, well, we have some kind of degree of how to say, of choices according to what are our inspirations. Like some of the solution architect doesn't want to do anything related to training, because they think that like giving more like developing training hands-on and so on, this is not their strength, and that, or they are basically not interested into teaching, for example, so they don't go for this kind of positions, and then they develop other strength in this case. So it really, really depends on what you would like to do. Of course, we have some responsibilities, and the first responsibility is to follow our customers and help them to develop their solutions. But other than that, like you can decide with your manager how you can, where you would like to learn or to improve in your career.
You mentioned about the your collaborators that you were helping. You said that you one of your projects was to basically assess the quality of their approach, or like what did you mean by the quality?
Well, to qualify, I think I said, but
Yeah,
but
qualify. My
actually,
bad.
yeah, but that's fine. So, well, basically, you know, like, let's say, of course, I cannot talk about like precisely about some customers, but let's think about, like a company who is having, let's say, a chatbot and would like to add, speech synthesis and speech transcriptions, for example. And the idea is to like where to start, like where are the models and how can I develop my own model, for example, for my specific languages? How can I adapt those models to understand basically the jargon of that company and so on? So where I work actually is to explain actually what is the trade-off. So today, the state of the art models that they can use, and what are the pros and cons of those models in terms of latency, throughput, cost, and so on. And also, like help them to qualify where they should go, and also how they could actually customize their basically solution based on NVIDIA solutions. So to give you an example for the speech AI, so we do have a solution called Riva for speech AI that will allow you to deploy speech transcription models and speech synthesis models, and those models are customizable. And I help actually customers in those POCs, like proof of concepts, in order to um, uh, basically help them customize, kickstart actually, and see how they could customize
Mhm.
some of the examples. Of course, like it's up to them to develop the entire application, but the idea is to have them kickstart developing the
Yeah.
solution.
Do you
Yeah.
see any resemblance with when you were doing your or either master's or PhD? Doing, I feel like proof of concept work is kind of similar to research or what you are doing in research as well. So,
Some kind of it's quite familiar to what I was already doing when I was on the research department, like also working on proof of concepts, like studying all what is going on in the research and trying to pick the best solution to solve a specific problem and so on. So that's something that is quite similar to my role today. Research is, like during the PhD is quite different, like because once you do a PhD, so at some point you have to choose an idea and kick stick to that idea and try to defend. This is what we call it,
yeah.
the defense of the PhD. So which is quite different, like you want to experiment to show and to prove actually in a research way that this solution is the best one or not, like in some cases. Well, proof of concept, we are more dealing with real world applications, with real world problems, and usually we need to make choices in terms of best in terms of accuracy compared to the best in terms of cost, in terms of latency and throughput. That's something that I was not that much experiencing during my PhD, because I would say usually we are more focused, at least in my field, I was doing more training AI models. So I was more focused on the accuracy itself, the performance of the model, like we needed to have better
Yeah.
performance, in the classification and recognition and so on. But today my role is more, like finding the best solution also in terms of like the application requirements. Like
Mm.
it's good, like to give you an example, there are some ASR or speech synthesis models that are much higher in terms of performance, accuracy, but they cannot be incorporated to a conversation, a human level conversation. If you need to you have a chatbot and you need to wait for 3-4 seconds to get an answer. That doesn't sound, very interesting, and many companies would not actually be interested in this kind of solutions. So yeah, so like the role today is more, like dealing with this kind of problem. So
Yeah.
it's not just about the performance in terms of accuracy, it's also about, can it be actually the solution for the problem?
Would you say that right now we are shifting from developing those models and basically more like a research industry towards an application industry where we basically just take the powerful models and try to make them productizable, like optimize everything and make them applicable to the real world, but the technology is already there?
Well, that's actually, I think this is the classic process, like for all, it's not just related to AI, it's
Yep.
for everything, like we start by doing research, finding the best solution in terms of performance, and then try to find a way to make it less costly in terms of latency, in terms of cost, and so on. So I think this process is also, like quite normal in
Mm.
AI, and we are definitively also there. So in many cases, we already started to find very, very good and very impressive, like AI models. However, some of them are still quite costly in terms of training, but also in terms of deployment. And now we see a lot of techniques, like that are developed for optimizing those models, whether, like at NVIDIA, we have several softwares that are dedicated to the deployment itself, in order to optimize, the model once it is trained. We're using like quantization techniques, using layer fusion, using some, sparsity, and so on. There are other techniques, like using model distillation and so on, in order to try to reduce those the cost, and the latency of those models, and in order to make them, like more effective
Yeah.
once we incorporate them into real world applications. And again, in some cases we fail because, like those techniques, like of model compression and so on, like the most difficult thing when we do that is to keep the accuracy of the models while we compress them. So some of the models are, like still not really responding very well to this kind of technique. So again, so you have to find that trade-off, like maybe in some cases you need to um, choose other techniques that maybe are less performant in some cases, like, like you lose a little bit of performance, but you gain more in terms of latency and so on. So that's the kind of choices that we need to find. And hopefully, so like you need to do that before investing into data collection and training and so on.
Do you reduce the accuracy or the performances a lot when you try to make them more efficient, or do you actually successfully make it much more efficient while staying relatively similar?
Well, that's the entire research field of quantization
Yeah.
techniques and optimization techniques. So today for computer vision, for example, so for image classification, image segmentation, and so on, so we have some techniques that are quite well known. So at NVIDIA, we have a software called TensorRT that uses model quantization, but also uses some layer fusion and so on in order to optimize the model. And this works very well, actually, without a significant drop in the accuracy. In very large scale NLP models today. So we have some techniques, like to reduce the inference. One of them is to distribute the model itself in order to increase the capacity of the compute. But there are still some techniques that are still a little bit hard. Int8 quantization, for example, which reduces, like the precision of the weights of the model. In some cases, it's still not that much that successful. so yeah, so there are still things to be done in some cases, but in many other cases, for speech processing, for computer vision, techniques of quantization are quite yeah, famous, and they work very well. Like they quantize, those models quantize very well. Yeah.
And you just mentioned to distribute the model. So may I ask
Yeah.
for the audience, what do you mean by distributing a model and why would you do that?
Haha. Well, like you probably heard about those very large models, and especially in the field of computer vision and natural language processing. So we talk about those stable diffusion models that are capable of generating very like good images by just giving as input some descriptions, and you have a very high resolution of those images, or models like ChatGPT and so on that are basically based on very large language models. So those models are really big. So for instance, we're talking about the GPT-3 model. It's 175 billion parameter model, which is really big. If you do the math, this kind of models doesn't fit into the memory of one GPU. And this is why now we needed to develop technologies, algorithms, and also hardware technologies in order to distribute efficiently the model into several machines, either within a same node or within different nodes at the same time. So training those models today require this kind of distribution, and there are different type of distributing the model. So either basically there are two main techniques. So you take the neural network. So basically a neural network is based on several layers. So the first thing that you can do is to split sequentially the model. So let's say, for example, layer 1, 2, 3 into GPU 1, 4, 5, 6 GPU 2, and so on, and you do that. And this comes with a cost, like you do your forward pass, your backward pass, and each time you need to communicate the activations, from GPU to another GPU and so on. Another technique is to split the tensors itself. So this is what we call tensor parallel, where for the layer itself, we can split actually the matrices into different GPUs. And this comes with an extra cost in terms of communication between the GPUs. So this is why actually everything needs to be optimized. The interconnect between the GPUs, the connection, networking between the nodes needs to be optimized in order to actually optimize the communication during the training, but also during the inference in this case. But but if we focus on the training, so there are different techniques that we can use for that. And even with that, you will see that during the training, we are calculating the feature maps, so the activations, and we need to store them in order to be able to compute the gradients at the backward pass. So, and this takes, a lot of memory in this case. And there are different techniques in order to reduce this kind of the memory footprint during the training by, like saving. This is what we call activation checkpointing, for example. We save some of the checkpoints rather than saving the entire activations. And we pay with that, a more like extra recompute of some of the activations that we already recomputed. And this is how we gain some memory, for example, during the training. There are plenty of techniques that will allow you, to accelerate the training, to scale the model according to your infrastructure for that. Yeah. And once you train that model again, you end up with a very large model. And in this case, it requires, of course, distributing that model because it doesn't fit into one GPU, even if you quantize it again. So it's still very large model. So usually we do the inference in a distributed mode again. And if you are again, usually at the inference time, we are also, dealing with the latency. So in this case, we need, like to distribute efficiently the model in order to accelerate the inference.
And that just makes me want to come back to my earlier topic of research versus this is more like engineering work and and trying to apply those models. And so related to that, would you say that your PhD was worthwhile, or would you, yeah, just personally, what do you think of your own PhD, and do you think it was worth it in the end?
Well, it's a lot of sacrifice, when you do a PhD. It's a lot of personal, sacrifice and work, because like I don't know how it is in other countries. In France, usually it's 3-4 years of study. But I would say it is worth it because, like in addition to the expertise that you gain in your specific domain, for instance, in my domain, I was using machine learning applied to speech processing and also to computer vision. So I gained some expertise in those two domains, but I think there are some other skills that you gain during the PhD. One of them is to learn actually how to structure your ideas, to structure the way of thinking, and also how to communicate that efficiently. So you need during the PhD, so you are most likely you will be writing papers, scientific papers about your experimentations. So in this case, you will need, like to have some skills in order to explain actually in clear way how you did your experimentation. And also you need to proof, like somehow your hypothesis in this case. So I think it's a way of structuring, a way of working and seeing and how you take actually a problem and how you approach a problem. So this kind of skills, it's quite hard, to teach, but you gain them naturally, I would say, while you are doing a PhD. So yes, I would advise anyone, if you are motivated, and again, I have to say, PhD is a lot of also work. If you are motivated and I would like to experiment and do research and also defend some hypothesis that you are, or like some cases, like you start from a hypothesis and then it occurs that it was wrong, and it's fine, like that. If you could show how, like by reasoning, how you ended up by saying this hypothesis is wrong, this is actually adding something into the research field. So yeah, so there are some additional skills that I think they are worth and are helpful in your career in general and as a data scientist also.
Would you say that it would be required as a data scientist to become the best data scientist you can be, or there are other ways to
No,
get those skills?
I wouldn't say it is required to be a data scientist at all. Like there are plenty of very good examples of a very, very talented data scientist that doesn't have a PhD. So I wouldn't say that, but as I said, like in my experience, the PhD allowed me to, like gain more extra skills. I would say that are very helpful today. But this is not necessary, like to be a
Yeah.
very good data scientist. Yeah.
And just to have your personal feedback on that, from, for example, someone coming from another field, completely different field, how would you suggest this person to make his or her transition into data science? For example, if by watching this interview, this person wants to do the same thing as you are doing, what would you recommend this person to do or to start with?
Well, today there are a lot of tutorials, a lot of online training that you can find, and there are very, very nice trainings. My advice is to start by a mix between theory and practice. Like there are very nice tutorials of solving concrete problems, with even with open source data sets, with, like just hands-on examples that will allow you to gain expertise very, very quickly, like on how to solve those problems. But my advice is to couple that with some theory, because I think you can do the job by just following the tutorials that you can have here, like today available. Uh, but the data scientists, they have several responsibilities, and one of the roles is to be able to choose the right solution for the problem, and also be able to experiment and in some cases explain why the behavior of the model. Uh, why I'm saying that, like explaining in terms of like why my model didn't converge, what happened to the model, like at that time, why it converged faster or less faster, and so on. And I think it is important to have like a level of understanding on how machine learning works, and how, or in general, also deep learning models work, how we train them, how they converge, and so on in general, in order to be able to have that level of, like just explaining how things are going, and why it requires more data, for example, and so on.
So you would say that having a good understanding of what's going on is important compared to, for example, I share that it's important to work on something that is applicable. For example, if you want to learn machine learning, I think that it's interesting to actually build something, a web app or anything, just make it online. And so you will add to that that it's also important to take the time to learn a bit of the theory behind it and understand what's actually going on, not just go trial and error and like spam your way until it works.
Yes, indeed. I think both are important, like because I think by doing yourself, you learn a lot. So like make the tutorial, take them, like take some data and try to train the models and see how the models are trained, and so on. So I really think that this is very helpful, and this is um, very interesting to understand, like how to do the work. But as I said, like mix that with some theory in order to
Yeah.
understand what's going on.
And speaking of which, are there any tools or tech stack that you are using or you would recommend someone starting in the field to use? For example, just when we speak of programming language like Python or libraries or just useful tools for data scientists in general.
I would say it really depends on what you want to solve. If you are starting, like there are books, there are tutorials, there are like that you can find online. I would encourage you to go to Nvidia developer website. You will find some hands-on there with the Deep Learning Institute, like very fundamental to very deep into how to program on a with CUDA, for example, or how to distribute the model to train very large models, and so on. Um, uh, Tools, I would say, like daily tools. There are many tools that data scientists use today, like from scikit-learn, Panda for data pre-processing. We do have a GPU accelerated data processing tool called Rapids for that also. So if you want to have a look at that, and for training AI models, so there are many tutorials with the popular frameworks, PyTorch, TensorFlow, and so on. Data scientists usually we like high level
Yeah.
coding, like Python. It's quite familiar for data scientists. For people who are more willing to learn the optimization techniques, and for the deployment, for example, usually we are more willing, like digging into the code and to basically C++ in order to optimize the inference. Yeah, and for the training itself, like there are several tools if you want to optimize your training. There are tools that will allow you, to profile your code. Uh, PyTorch, are having a very good tool called PyTorch Profiler. At NVIDIA, we have a tool called Insight System that will allow you to trace CUDA operations. And all of those tools will allow you actually to dig into what is happening exactly in your memory, in your GPU, and so on, in order to see what are the bottlenecks and how you could solve them. So plenty
I
of tools.
Yeah, indeed. And I just because when I was starting during my masters, I focused especially on understanding what was going on with the model itself and like how the images or information was propagated throughout the network and everything around the artificial intelligence side. But I never tried to, back in the day, I never tried to understand what was going on with the memory and the compute and GPU and everything. So you would recommend to also dive into that even when starting right now.
Oh, yes. Well, especially that today, like the trend is to go for very large models,
Yeah.
either in computer vision, and we see it also in speech processing. We are going to very large models in this case. And in this case, it's worth, like before starting any training to profile benchmark your code. The code matters a lot, like you have to have an optimized code. Sometimes you could gain, few seconds per iteration, but those few seconds, once you scale to
Mm.
larger models, it's a lot of compute. So yes, I would advise you, like to have, a look very quickly once you are starting benchmarking, to have very quickly some measures about the throughput, the latency of your training, and where are the bottlenecks. Have a look at the memory used and how you can optimize that entire pipeline. Also, you don't need to build everything. There are also very well-known techniques that will allow you to, like just kickstart with optimized libraries. So just need to have a look at what is existing as tools, and have a look. Again, like I used to say that it's also according to your hardware configuration while you scale. For example, if you have a optimized communication between your GPUs, for example, or not. So there are some distribution strategies that would be more costly in terms of communication than others. So in this case, you have to profile your training and see if actually one of the distribution techniques is better than the other ones according to the hardware infrastructure that you are
Mm.
having. So that's something that basically before starting the training, we kickstart by very few examples. We benchmark and optimize the code before really starting and scaling the training in this case. Yeah. And there are really very, very good tools today to profile all the type of things that are happening in your computer.
Mm. And this can be very interesting when your compute is limited, especially for people that are starting. I have a question regarding that. Is a lot of I get very often people asking if they should buy a completely new PC for getting into the field, or what tools should they use, like Google Colab or something else to code and learn AI. What they basically ask, what material do you need when wanting to learn AI and just practice. So what would be your recommendation on that? Of course, it depends on the budget, but like what would be the easiest way to get in? Let's see.
Well, it's very hard for me to answer to that question. Of course, we are going to more and more intensive algorithms
Yeah.
for training AI. Again, you don't need to train till convergence to understand. If you are in the learning process, you don't need to go for, well-trained AI models to understand how to train them. Of course, if you go till convergence, it's much better for you because you will have also some models to evaluate and to see how they behave in downstream tasks and so on. But today you can find, solutions of already pre-trained models that are available on many different repos. So at NVIDIA, we have what we call the NGC repo, where you can find pre-trained models that you can take, trained with the popular frameworks such as PyTorch, TensorFlow, and so on. And you can take them and evaluate and continue fine-tuning them and so on. So again, so if you are in the learning process, so there are plenty of solutions that will allow you to reduce the compute that needed for your learning process. But if you want to develop a solution, in this case, a concrete solution to solve a problem, in this case, at some point you will need to have some
Mm.
level of investment, because those models, they require compute, they require also data set, and very good data set in some cases. So yeah, so infrastructure at the inference and so on. So yeah. But for the learning process, my advice is, like to kickstart just training to have an idea of how to train those models. And if you want to go for the evaluation, there are already pre-trained models
Mm.
that you can fine tune with less compute in this case.
Yeah, indeed. And even for building an application, it's often much better to start with a pre-trained and then fine tune it with much less data.
Yes, of course. So that's something that is really great with the deep learning models today that are, having this encoder decoder
Yeah.
architecture, where actually the encoder part would be more trained to as a feature representer, I would say, while the decoder would, like solve the,
Yeah.
the problem that you are dealing with. So this encoder part, actually, you could take advantage of that part and do the transfer learning and use that pre-trained model to solve another problem. So that's something that at NVIDIA we work on a lot. So we do provide some pre-trained models that were trained on either open source data set, and in some cases on proprietary data at NVIDIA, and we train them for hours of hours of compute. And you can kickstart with those models and continue fine tuning them for your own problems, for instance.
Yeah.
So that's the idea. It's reducing the amount of effort actually in order to develop the model itself. And we are today making use of fine-tuning models either on computer vision, on speech processing today. So we are using, even for speech transcription, we are transfer learning from a language to another one,
Mm.
and it works very well. Like in some cases you don't have enough data in some specific
Yeah.
language, but you would like to have accurate feature representation of a speech.
Mm.
So we take a model that was pre-trained, let's say, for a large, usually we have some, languages where we have a high resources, and we fine tune those models on low resources data sets, for example. And this works very well.
And continuing on the path of learning, I will just make the smooth transition into the GTC event coming, where you mentioned workshops, basically to learn like all the way through for the data science process and everything. But there's also a lot of cool events, like for example, just continue speaking with you and learning more from experts. So I would love if you could just summarize the events you are participating in and how people can learn more after this interview.
Okay, so as you mentioned, so GTC, which is the GPU Technology Conference at NVIDIA, is coming soon. It will be in March. This is fully online and free registration. So if you would like to join us, this is really a great opportunity to hear about new technologies that NVIDIA is developing, either on the hardware stack and also on the software stack, and also to hear, like customers and partners talking about how they are using NVIDIA technologies to solve their own solutions. During GTC, we are having some what we call DLI workshops. So training workshops. I will be basically teaching the building transformer based applications. So this is an 8-hour course of with some hands-on on how you can work with transformer model, pre-trained model, fine-tune them. Of course, we will not go into convergence in of like a very large pre-training, but this is the idea is to give you kind of kickstart pre-training on those models. And we are having some sessions on what we call Connect with Experts. I will be participating into one of the sessions in EMEA time zone. So the Connect with Experts is basically, again, so this is fully online this year. So it will be a virtual, room where we will be discussing, there will be several experts I will be there discussing about technologies related to conversational AI in general, speech processing and natural language processing. And you will be able to submit your questions. We will be also able to go into smaller virtual rooms where people could switch on their camera and like we can have like a friendly discussion about the technology, state of the art, and so on. So yeah, feel free to join and always happy to discuss about my favorite topics.
Yeah, that's super cool. If you've enjoyed this interview, I definitely recommend to tune in to this event. And also the workshop I think is very exciting, very interesting, and it's like completely relevant to what's happening right now. So super cool events, and I definitely recommend attending GTC. So thank you very much for this interview. This was super interesting, and thank you for your time, Meriem.
Thank you. Bye bye.
Bye.